Okay, welcome to this lesson then on prime factor decomposition. We're making prime factor trees in this video. This is an essential skill, all right? So before we start this video, you should know already what a prime number is. If you don't, then you need to do some more reading before you come onto this video, okay? So I'm going to assume you know what a prime number is. So here's our first example, all right? Our first number we're going to break down into prime factors with using it by making a tree is 12. Okay, so I'm just going to start with number 12. I'm just going to think, first of all, any two numbers that multiply to make 12. So any factor pair of 12. All right, well, maybe 3 times 4 is 12. All right, could have picked 2 and 6, couldn't we, as well? Obviously, 1 and 12 would be pointless. All right, so yeah, 3 and 4 or 2 and 6. Now, you should know already that 3 is a prime number. If you hit a prime number, you can circle it and stop there, okay? This part of the tree is finished. 4 is not prime, though, and the only way to break 4 down into a factor pair is 2, which is prime, and 2, which is prime. And the tree is now complete. So you can check now, all right? 12 is 2 times 2 times 3. We can check because 2 2s are 4 and 4 times 3 is 12. This is the prime factor decomposition of 12. 2 times 2 times 3. And again, you should know a better way to write this would be 2 squared because there's 2 2s times 3. So 12 is 2 squared times 3. If you had done 6 times 2, it wouldn't make a difference. This method is cool because whichever way you do it, you get the same answer in the end. If you had done 2 times 6, well, 2 is prime, 6 is not prime, 6 is 2 times 3. 2 is prime, and so is 3. So can you see? You get the exact same answer. So whichever way you start off, if you do the tree properly, you will get the same answer in the end. All right? So here's our example 2, 36. Perhaps pause the video, have a go, and then come back when you're ready, is it? Okay, welcome back. So 36, in it, many choices. 4 times 9, 12 times 3. I probably would do 6 times 6 is 36. 6 is not prime. It's 2 times 3. But 2 is prime, and so is 3. On this 6 as well is also 2 and 3, which are both prime. So we're finished already. So 36, you could write like this, couldn't you? 2 times 3 times 2 times 3. I think a better way would be to pair the numbers up or put it in ascending order of primes. So I think 2 times 2 times 3 times 3. Because obviously, multiplication, remember, is a commutative option. All right, the order of multiplication does not matter. So I can switch them around. This just looks better here. All right, and again, in index notation, it will be 2 squared because there's 2 2s times 3 squared because there's 2 3s. All right, and again, if you want to check, you can, because 2 times 2 is 4. 4 times 3 is 12. And 12 times 3 is 36. Or even this way, 2 squared is 4, 3 squared is 9, 9 times 4 is 36. So we're correct. Easy. Right, last one, example 3, have a go. Pause the video, come back when you're ready. Nice one. Right, so welcome back. 105. Few options here, but if it ends in a 5, I know 5 will be a factor. So I think it's 5 times 21. It is 21 5s are 105. 5 is prime. 21 is not prime. 21 is actually 3 times 7. 3 is prime, and so is 7. So if I do it in ascending order, 105 is 3 times 5 times 7. You can't write this in index form because there's only 1 3, only 1 5, and only 1 7. All right, so this is actually fine as it is. And if you want to check, 3 5s are 15, and 15 times 7 is definitely 105. All right, so we are done. Easy. Now, for some numbers, the tree gets quite big. It might go down more than 2 levels, but it's fine. There's a main task here you can have a go at. All right, you could pause the video, have a go at these, and see how you go. So come back when you're ready for the answers, okay? Okay, welcome back. So I've done all the answers in index form. All right, you may have noticed there's a few cheeky ones on here. Also, just one cheeky one actually, isn't it? That 31 is actually just 31 because it's already a prime number. Okay, so there's the answers there. Hopefully they're all correct. I've used index notation to speed things up as well, like you should do. And here's the checking question, okay? So pause the video here, have a go, come back when you're ready. Okay, welcome back. So it says, which number's got more distinct prime factors, 48 or 128? Well, remember, the word distinct means different. Okay, so I think I better take both these numbers, find their prime factor decomposition, and then answer the question. So 48, yeah? Shall I go for 4 times 12? I reckon. 4 is 2 times 2, both prime. 12, well, 2 times 6. And then 6 is 2 times 3. So 48 is 2 times 2 times 2 times 2 times 3, or 2 to the 4th power, because 4 of them, times 3. All right, so I hope you can see that 48 has only got 2 distinct prime factors. All right, it only contains a 2 and a 3. So 48 has got 2 distinct prime factors. And you might think, because 128 is a bigger number, you would have more, but 120 is a really cool number because what should we do? Well, it's definitely even, right? So I could go for 2 times 64, I think. Yep. And then watch this now. 64 is also even. So I think that's 32 times 2. 32 is also even. So I go for 16 times 2. 16 is even. See where this is going? 8's even. And 4's even. All right. And then we're finished. So I'm not writing all these 2's. All right. 48 is actually a very even number. It's 2 to the power of 1, 2, 3, 4, 5, 6, 7. 2 to the 7. And so you see 128 actually only has 1 distinct prime factor. Well, actually just 1 prime factor, I suppose. All right. It might look like a cool number, but actually it's quite, well, it is interesting and boring at the same time. So in this case, the answer is 48. 48's got 2 distinct prime factors. 128 only has 1. Okay. And that's it. So thanks for listening. Thanks for watching. Stay safe. We'll see you soon. Nice one.